to this day, Earth is the only planet we know of that has active tectonic plates. Tectonic plates are essentially a fractured crust that constantly move over a molten mantle, and it essentially makes the surface of the planet active versus a dead, static world like Mars. And there is some mounting evidence that this activity, having a world that is not static, is crucial in the evolution of life, because this activity constantly creates change, whether it's the formation of new mountain ranges, the opening up of new oceans, the recycling of nutrients, and just general change in the weather and the climate, which provides a fantastic stimulus for the evolution of life. Now, tectonic plates will eventually come to an end on Earth as the mantle slowly cools off over time. We think this happened to Mars, with its hypothetical tectonic plates freezing up about 1 to 2 billion years after the formation of the planet. Mars is a lot smaller of a body than Earth. It doesn't have a big moon which pulls on it gravitationally, warming up the interior. So when we extrapolate this cooling to the Earth, we should remain active for about another 5-ish billion years. So that's nothing to lose sleep over, because in just 1 billion years, Earth is going to become uninhabitable anyway due to the intensifying solar radiation from the aging sun. But getting back on topic, this is a cool animation of how the continents on Earth have changed historically over time. And you can see the world map today by comparison is way cleaner and less fragmented than it used to be. But as established, this activity is still ongoing, and the plates on average move about 1.5 centimeters per year in this direction currently. But this is just an average, and some plates like the Australian plate are speedrunning super fast, and others are in comparison rather chill. Now, due to the complexity of this system and all of the interactions, it is still unclear as to the exact future layout of continents on Earth. A general consensus here is that another supercontinent is almost inevitable, but the exact where, how, and when is unclear. But one interesting projection I want to share is the Amasia model. In this projection, we have a supercontinent form as all the landmasses smush together and congeal around the North Pole, except for Antarctica. Antarctica is still in the exact same spot. Taking a closer look, we see Africa smashes into southern Europe, completely deleting the Mediterranean Sea, and instead is going to create a new huge mountain range. We can see that Australia is doing a similar thing. It continues its current trajectory up north until it eventually smashes somewhere into Asia, again creating a new mountain range, pretty similar to how India smashed into Asia, creating the Himalayas. In the Western Hemisphere, we can see all of Hispaniola slowly moving up the US East Coast. South America also kind of awkwardly puts itself underneath North America. And then ultimately these two halves come together, they close off the Arctic Ocean, and they meet at the North Pole. This will leave us with a huge landmass in the Northern Hemisphere that probably has way more mountain ranges. Now, it's always fun to think about the climate consequences of such a future event, because aside from the composition of the atmosphere, Milankovitch cycles, and things like that, the placement of landmasses on Earth's surface has an unbelievable impact on its climate. A great example of this is the huge temperature difference today between the Arctic and the Antarctic. These two regions are essentially the inverse, because the Arctic is an ocean and the Antarctic is a landmass. And whenever you have land over the polar region, it allows for the formation of ice caps, and these create a positive feedback loop of lower temperatures by reflecting sunlight, cooling down the planet even more. So in this hypothetical future, where we still have Antarctica at the bottom of the world, and essentially a new larger version in the northern hemisphere, this would potentially be a much cooler planet Earth versus what we have today. And we might even develop a second circumpolar current. So today, around Antarctica, we have what's known as the Antarctic Circumpolar Current, or the AAC, which is an uninterrupted current of cold water circulating Antarctica. And this is possible due to the location of the continent and the land masses, or the lack thereof, around the continent. And this circulation of cold water around the landmass is another factor contributing to the extreme cold temperature that is currently found in Antarctica. It essentially blocks any warm water from reaching the landmass. And in this hypothetical future layout of the continents, we could easily develop a second circumpolar current around the northern hemisphere as well. And that could lead to a drastically different world and climate than what we have today, simply based off of the location of Earth's landmasses. If you guys like this kind of content, make sure to subscribe, leave a nice comment, and I'll make more in the future.